Hello again. This is lesson 2 of unit 6 on exponents and radicals. This lesson we'll be learning about multiplying monomials. So let's take a look at our note sheet here in our packet, and we'll look at the first two steps and the product rule. Step 1 is that you want to multiply the coefficients. Step 2, you want to use the product rule to simplify the exponents. Well, what is that exponent rule? Essentially what that is that you're going to add the exponents if the coefficient is the same. So if we have x to the mth power, where m can be any number, multiplied by x to the nth power, which will be any other power other than m, you just add those, so that would equal x to whatever m plus n equals. So that is our product rule. Let's look at some examples in the numbers below. For number 1, we have x squared plus x to the third power, or what we call x cubed. So we just add those two exponents, so that would give us x to the fifth power. Number 2, we have a to the ninth times a. A just means a to the actual first, but we don't actually put that 1 there, it's just kind of understood. So 9 times 1, or 9 plus 1 would be 10. So 9 to the 10th power. For number 3, we have 4x squared times 3x to the 5th. What we do with those numbers in front of the coefficients is we actually just multiply them just like we would normally. So 4 times 3 would be 12. X to the second power times x to the fifth power. We add those together. That would give us x to the 7th. So there is our answer. So I'm going to pause here and ask you to pause the video and do numbers 4 through 9 on your own. And then once you finish those, unpause it and check your answers. Here are the answers for 4 through 9. Let's take a look at these. Of course, if you go through this video and you get a different answer, try to work the problem again to see if you can get the right answer. If you still don't get it, then when you come to class, call me over and I'm happy to help you out in order to figure out where you went wrong. So let's look at these. Number 6 is a little bit of a tricky one. As you can see, we have different variables in this, but still we just apply the same rule. We have a to the third and a to the second, so that gives us the a to the fifth, and then b to the first and b to the fifth, so that gives us b to the sixth. And we just combine everything else. Negative 4 times 3 would be 12. So hopefully that makes sense when you look at the rest of the answers on this example sheet. When we look at the rest of the ones on the sheet, see if you can go ahead and follow that same rule. And don't be scared by number 16 through 19. It looks very complicated with all those extra letters or variables in there, but it's not that difficult. There are the answers for 10 through 12. Again, just look at the common exponents, add the exponents that have the common coefficient. In this case, in number 10, we have m's and m's here. So that's 2 and 1 will give you the 3. And with the n's, we have n to the first, n to the fourth, so that gives us n to the fifth. We have 6 and 7 multiplied together, that gives us the 42. Same thing with 11. We have c squared here and c cubed here, so that gives us c to the fifth when we add the exponents. We have d to the first, d to the fifth, That gives us d to the 6, and 8 times 10 gives us the 80. The number always goes in front of the exponent, so just remember that. Over here, same thing. We just distribute this to this, the negative 4 to the rs squared. That essentially gives us negative 4 rs squared. Negative 4 times negative 5 is the 20. R to the first, r to the fourth gives us r to the fifth. S squared plus s gives us s to the third. So let's look at 13 through 15, which have some fractions, which I know are scary, but we just need to make sure we distribute it properly. So negative 6 times 1/2, remember when we're multiplying fractions, we just multiply straight across. So that would be negative 6 times 1 gives us negative 6 over 2. And that's the same thing as negative 3. So I'm going to cross that out because we don't have that. So negative 3. A squared plus or times a to the first would be a to the third power. And then b times b would give me b to the second power. For number 14, so 12 times 2/3, we multiply straight across. So 12 times 2 would be 24 over 3. 24 divided by 3 is the same thing as 8. We have that x comes before the y, so in our answer we need to have x before the y. As you can see, here's the x before the y. And then we have y to the first times y to the fourth, so that gives us y to the fifth power. Number 15, we have 1/4 times 8. We multiply that, that gives us 8 over 4, which is 2, and then 2 times the negative 6, that gives us a negative 12. Then we have to combine our variables. We have m to the first and m to the second, so that's m to the third when we add the exponents. Then we have n and n squared, so that's n to the third. So, given all that, let's look at a few more examples, 16 through 19. Here we're just combining what we learned in lesson 1, which was adding and subtracting monomials. Here we're going to be doing that, but first, following the order of operations, we're going to do multiplying first and then adding them. So let's look at 16 together. We want to look at these terms here, 2x to the fifth y squared times 4xy to the third. 2 times 4 would be 8. X to the fifth and x would be x to the sixth. Y squared times y to the third will be y to the fifth. Then we have a plus sign. Then we have x to the fourth times y to the fourth times 3x squared times y. So we have that 3 that hangs out first. X to the fourth and x squared is x to the sixth. Y to the fourth and y gives us y to the fifth. Now when we add these, remember when we add exponents, or excuse me, when we add coefficients that have exponents, we only combine the ones that are the same. So we have 8 plus 3, that gives us 11. We have x to the 6th right here, and x to the 6th there, so we can carry that with it. And then we have y to the 5th on both of them as well. So let me erase all that and return it, rewrite the answer so it's nice and clear for you to see. So it's 11 x to the 6th, y to the 5th as our final answer. Let's look at another one together, number 17. First thing we want to do is look at the first set. We have 4 times 5, that gives us 20. A to the third and a to the first So that gives us a to the fourth, then b to the fourth and b to the second. That gives us b to the sixth power. Plus, we have this -2 hanging out. I'm going to put that in parentheses. A to the second, so that's a to the fourth, b to the fifth, and b to the first. That gives us b to the sixth. Now we can combine the things that are the same. So we have 20 plus a -2. That gives us an 18. We have a to the fourth on both of these, so that carries over, as well as b to the sixth. So since they have the same coefficients and exponents, we can combine them. Go ahead and pause the video right here to try number 18 and 19 on your own. When you are done, unpause it and check your answer. There are the answers for 18 and 19. Certainly, as I said before, if you have questions, if you didn't get the right answer, come see me in class and ask questions for clarification. Otherwise, that completes our lesson 2 on multiplying monomials.